Astonished, this detected something that shouldn't exist. A black hole spinning so fast, it's literally breaking the laws of physics as we know them. M87 is rotating at 80% the speed of light. That's 240,000 kilometers per second. And what scientists discovered next will completely change how you see the universe. Imagine a cosmic monster so massive it contains 6.5 billion times the mass of our sun. Now imagine it spinning like a galactic tornado, warping space and time itself. This isn't science fiction. This is happening right now, 55 million light years away from Earth. Anxious for decades, scientists thought black holes had limits. They believed there was a cosmic speed limit that nothing could approach. But M87 just shattered every prediction we had. It's spinning at velocities that make our fastest spacecraft look like they're standing still. Interested, but here's where it gets truly mind-blowing. This black hole isn't just fast. It's 38.9 billion kilometers across. Astonished. That's 3,000 times wider than Earth, stretching further than the orbit of Neptune. Try wrapping your mind around that scale. Ruth Daly from Penn State University couldn't believe what she was seeing. It's not just a huge mass, she said. It's a force that shapes everything around it. And by everything, she means entire galaxies, star systems, and the very fabric of space itself. Delighted, the Event Horizon Telescope captured something impossible, a direct image of this cosmic beast. By linking radio telescopes from Hawaii to the South Pole, they created a virtual telescope the size of Earth itself. This is the same black hole that became an icon in 2019. But wait, how can you photograph something that swallows light? The answer is brilliant. Scientists don't see the black hole directly. They observe the glowing plasma being torn apart just before it crosses the point of no return. It's like seeing a shadow cast by pure gravity. Astonished, those plasma jets shooting from M87, they're traveling at nearly the speed of light themselves, extending for thousands of light years. These jets are so powerful they actually influence how entire galaxies form and evolve. One black hole shaping cosmic evolution. Think of M87 like a cosmic drain, but one that spins so fast it creates whirlpools in space-time itself. The faster it spins, the more matter it can devour. And all that consumed matter gives it even more energy to spin faster. It's a runaway cosmic engine. Here's what keeps astrophysicists up at night. General relativity predicts there should be a maximum spin rate for black holes. M87 is pushing dangerously close to that theoretical limit. What happens if a black hole spins even faster? Nobody knows. The numbers are staggering. Every second, M87 travels 240,000 kilometers while spinning. Astonished. That means in the time it takes you to blink, this monster has moved further than the distance from Earth to the Moon, and it never ever slows down. But M87 isn't just breaking speed records. It's actively preventing new stars from forming in its galaxy. By swallowing dust clouds before they can collapse into stars, it maintains a delicate thermal balance. One black hole controlling an entire galaxy's destiny. NASA's James Webb Space Telescope is revealing even more mysteries. While the Event Horizon Telescope captures radio waves, Webb sees the infrared glow of superheated matter. Together, they're painting a picture of physics at its most extreme. Two eyes on the impossible. Scientists used to think black holes were simple, just massive objects that consumed everything. But M87 proves they're dynamic engines of creation and destruction. This single object is rewriting our textbooks on gravity, space-time, and the nature of reality itself. Interested, the plasma surrounding M87 reaches temperatures of billions of degrees. That's hotter than the core of any star. Astonished, matter at these temperatures doesn't behave like anything we know. It becomes a fourth state, more extreme than anything in our laboratories. And get this, M87 is relatively close to us in cosmic terms. At just 55 million light years away, it's practically in our backyard. That's why its radio waves are so bright and clear. We're witnessing extreme physics from the best seats in the house. Anxious, the rotation creates something called frame dragging. Imagine space-time itself being twisted like taffy around the black hole. Any object that gets too close doesn't just fall in, it gets caught in this cosmic whirlpool and spun around at incredible speeds. This discovery challenges everything we thought we knew about cosmic limits. If black holes can spin this fast, what else have we gotten wrong? Are there even faster ones out there? M87 might just be the tip of the cosmic iceberg. The Event Horizon Telescope network is expanding. Soon we'll have even sharper images and might discover black holes spinning even faster than M87. Eager. Imagine capturing these cosmic monsters in real time, watching them devour entire star systems. But here's a mind-bending question. What's the view like near M87? Time itself would slow down due to the intense gravity. From the black hole's perspective, the universe would appear to speed up, with millions of years passing in seconds. The energy output from M87 is incomprehensible. Every second, it releases more energy than our sun will produce in its entire 10 billion-year lifetime, all from matter spiraling into oblivion at near light speed. Pure Einstein physics in action. Those plasma jets we mentioned, they're not random. They follow the black hole's spin axis perfectly. Like cosmic lighthouses, they beam energy across millions of light years, potentially triggering star formation in distant galaxies. Sirius M87 sits at the heart of a massive elliptical galaxy. This isn't coincidence. The black hole and galaxy evolved together over billions of years. Which came first? Did the black hole create the galaxy, or did the galaxy birth this monster? Science still debates this. The mass of M87 is so extreme it bends light from distant galaxies behind it. This gravitational lensing creates multiple images of the same objects. Astronomers use this effect like a cosmic magnifying glass to study even more distant parts of the universe. But wait, there's more. The spinning black hole creates magnetic fields trillions of times stronger than Earth's. Astonished, these fields accelerate particles to speeds that would make the Large Hadron Collider jealous, nature's ultimate particle accelerator. Curious, remember those 40,000 kilometers per second? That speed creates relativistic effects we can actually measure. The plasma glows differently on the approaching side versus the receding side. It's called relativistic beaming, and it's absolutely wild. Nervous, some scientists worry M87 might be approaching a critical threshold. There's a theoretical maximum spin called the Kerr limit. Beyond that point, the mathematics of general relativity start to break down. We might be witnessing physics at its absolute edge. Astonished, the shadow of M87 isn't perfectly circular. It's warped by the spin. One side appears brighter because plasma moving toward us gets boosted by relativistic effects. We're literally seeing Einstein's predictions play out in real time across cosmic scales. To put this in perspective, if Earth spun as fast as M87 relative to its size, a day would last just milliseconds. The centrifugal force would tear our planet apart instantly. Yet M87 holds together through sheer gravitational might. That's the power we're dealing with. Interested, the discovery required perfect synchronization of telescopes worldwide. They had to account for Earth's rotation, atmospheric interference, and even continental drift. It's like trying to read a newspaper on the moon using binoculars, except a trillion times harder. M87's jets influence an area larger than entire galaxy clusters. We're talking about effects spanning millions of light years. Astonished, Blake M87 Stro. This changes our understanding of galaxy evolution completely. Black holes aren't just endpoints for matter. They're cosmic engines driving galactic development. M87 proves that black holes are active participants in shaping the universe we see today. But here's what's really keeping scientists awake. If M87 can spin this fast, theory suggests even faster ones must exist. We might discover black holes spinning at 90%, or even closer to the cosmic speed limit. What happens then? Delighted, the data from M87 is helping us understand quasars better. These ultra-bright cosmic beacons are powered by similar spinning black holes. Interested, M87 is like a nearby laboratory for studying the most energetic phenomena in the universe. The black hole's spin actually creates a region called the ergosphere. In this zone, space itself is dragged around so forcefully that nothing can stand still. Even light gets swept up in this cosmic carousel. It's forced to rotate with the black hole. Energy extraction from spinning black holes isn't just science fiction. The Penrose process shows how advanced civilizations could theoretically harvest energy from the ergosphere. M87 contains more usable energy than humanity could ever dream of consuming. The plasma temperature around M87 varies wildly. Some regions are billions of degrees, while others are surprisingly cool. These temperature differences create turbulence that generates the powerful jets we observe. It's like weather, but with physics turned up to 11. What if M87 suddenly changed its spin rate? The effects would ripple across its entire galaxy. Star formation rates would shift, planetary systems could be disrupted, and the cosmic balance would be thrown into chaos. One black hole holds immense power. The discovery technique is revolutionary. By combining data from multiple wavelengths, scientists created a complete picture. Radio waves show the jets, infrared reveals the hot gas, and X-rays expose the most violent processes. It's like having superhuman vision. Astonished, M87's gravitational field is so strong it creates closed time-like curves near the event horizon. In theory, this means time loops could exist in the most extreme regions. While we can't test this directly, the mathematics suggests reality gets very strange near spinning black holes. The black hole's spin affects how it feeds. A faster spin means a smaller innermost stable orbit, allowing matter to get closer before plunging in. This makes M87 incredibly efficient at converting matter into energy, far better than any process we know. Anxious, some regions near M87 experience time dilation so extreme that seconds stretch into years. If you could somehow survive near the event horizon, you'd watch the universe age rapidly around you. It's the ultimate fast-forward button for cosmic evolution. Delighted, the magnetic fields around M87 are perfectly organized despite the chaos. They form beautiful helical patterns that guide the plasma jets. It's like finding a perfectly choreographed dance in the middle of a cosmic hurricane. Order from absolute chaos. This discovery validates predictions made decades ago. Theorists calculated that spinning black holes should create these exact effects. M87 proves that our mathematical models of extreme gravity actually work. Einstein would be amazed at this confirmation. But M87 also reveals gaps in our knowledge. We still don't fully understand how the jets form or why they're so stable. The more we learn about this cosmic monster, the more questions arise. Each answer spawns 10 new mysteries. Astonished, the precision required to measure M87's spin is mind-boggling. Scientists had to account for effects smaller than the width of an atom viewed from Earth. It's like measuring the speed of a spinning basketball on Mars using only a pair of binoculars. Curious, M87 might hold clues about dark matter. The way matter behaves near the black hole could reveal properties of invisible matter. Some scientists think spinning black holes might be natural dark matter detectors, one mystery solving another. Amazed, the energy density near M87 exceeds anything in the known universe. Matter gets compressed and heated to states that existed only in the first moments after the Big Bang. We're essentially looking at a window into the universe's violent birth. Future observations might catch M87 swallowing a star. When this happens, the black hole flares up dramatically. Astonists estimate this cosmic feast occurs every 10,000 years or so. We might be the lucky generation to witness it. Anxious, the implications for physics are staggering. If black holes can spin this fast, it affects everything from quantum gravity to cosmology. Textbooks are being rewritten, theories are being revised, and our cosmic perspective is shifting dramatically. Curious, M87's spin creates gravitational waves, ripples in space-time itself. While too low frequency for current detectors, future space-based observatories might catch them. Imagine listening to the cosmic symphony of a spinning black hole. Surprised, the shadow of M87 actually wobbles slightly over time. This wobble tells us about the turbulent flow of matter in the accretion disk. We're watching cosmic weather patterns play out around a black hole. It's absolutely mesmerizing. This discovery impacts our search for life. Understanding how black holes affect galaxy evolution helps us identify where habitable planets might form. M87 shows us that black holes are cosmic gardeners, shaping where life could potentially bloom. Delighted, the collaboration continues to improve. New telescopes join the network every year, sharpening our view. Soon we might see details like individual plasma clumps orbiting the black hole. The future of black hole science is incredibly bright. But perhaps the biggest question remains unanswered. Are there natural limits to how fast a black hole can spin? Or could we discover ones rotating at 99% the speed of light or beyond? The universe might be stranger than we dare imagine. Sirius, M87 forces us to confront our cosmic insignificance. This single object could swallow our entire solar system without noticing. Yet by understanding it, we prove that human curiosity and intelligence can comprehend even the most extreme physics. Every observation of M87 adds another piece to the cosmic puzzle. We're living in the golden age of black hole astronomy. From the first image in 2019 to discovering its incredible spin, we're witnessing history being made. What do you think we'll discover next about M87? Will we find even faster black holes? Could some spin backwards? Share your thoughts in the comments below. The universe is full of surprises, and we're just getting started. Thanks for joining us on this mind-bending journey through extreme physics. If you're as amazed by M87 as we are, hit that like button. Subscribe to stay updated on more cosmic discoveries that challenge everything we thought we knew. Remember, every time you look up at the night sky, M87 is out there, spinning at impossible speeds. It's reshaping galaxies and bending the very fabric of reality. The universe is far stranger and more wonderful than we ever imagined. Until next time, keep looking up